All right, here in section 2.2, we're going to be working with linear equations. So an equation is a statement that has two mathematical expressions that are equal. It's that equal sign that makes it an equation. Equations have equal signs. Equations have equal signs. If you don't have an equal sign, you have an expression. An equation has an equal sign. So you can have equations with one variable. You can have equations with two variables. You can have an equation with no variables. All of these are options as we're looking at this. Now, to solve an equation means to find all of the values for the variable that make the equation a true statement. Those answers are then called the solutions. And we've got a solution set. Two equations are equivalent if they have the exact same solution set. So if we're focusing on linear equations, a linear equation in one variable is anything that is ax plus b equals 0, anything that can be written in that form. So there are three cases that can happen. If this has no solutions at all, it's what we call a contradiction, and the solution set is empty. If it has every meaningful value as a solution, that means it's always true. And things that are always true, we call an identity. And the solution set is all solutions depending on what we're looking at. And then most of the time, we look at an equation that is satisfied by some, but not all of the values. Maybe x equals 3 works, but x equals 4 does not. And that is called conditional. So most of the time, we're talking about conditional equations. Some special cases are contradictions, which are never true. Solution set is the empty set. And identities, which are always true. All right, so we have 3 examples of linear equations and then a couple that are not linear. The thing that makes this guy not linear is the x squared. Can't have any powers other than 1 if you're going to stay linear. And again, the only thing that makes this one not linear is that square root, which again is its power. And so we can't have a power in there that is anything other than 1. Some of the basic properties of equality are the addition property of equality and the multiplication property of equality, which say that you can add some number to both sides and you still have an equivalent equation, and you can multiply both sides of an equation by something and also still have an equivalent equation as you are looking at that. So if we look at example 1, they've asked us to solve this equation. So we're trying to solve this for x. The first thing we're going to do is distribute the 2. So that's going to say 2x plus 6 equals negative 2 plus 3x. And then we could subtract 2x from both sides and add 2 to both sides. 6 plus 2 is 8 equals negative 3, 1x. So that would actually be our solution solved then. X equals 8 is our one and only solution to this equation. If we look at the next example, again, we're going to start with some distributions. Remember, there's a negative 1 there that needs to be distributed. So that would put me at 6x minus 2 equals 3 minus 1x minus makes that a plus 3. So then if we combine the constant terms there, we would have 6x minus 2 equals 6 minus x. So we could add the x to both sides and add the 2 to both sides. That would put me at 7x equals 8. Divide both sides by 7, and we would end up at x equals 8 over 7 for our solution there. So again, one solution for both of these. Those are the only numbers that you could plug in for x that make those particular equations true. That means those are examples of conditional equations. Sometimes they're true, sometimes they're not. Now, one way we can make this a little more complicated is to throw some fractions in there. Fractions always make things a little bit more challenging. Now, this first one is not too bad. X over 4 minus 2 equals 1 over 4. So I typically don't love fractions. So the first thing I would do is multiply everything in this problem by 4 to get rid of those fractions. So that would say x minus 8 equals 1 as we're looking at that. So then it's just a one-step solve from there. Add that 8 to both sides. X equals 9 is your one and only solution to part A. All right, in part B, we're looking at x plus 1 over 3 minus 1/2 of x equals 2 minus 1/6 of 2 minus x. All right, so I've taught this class a lot of times, trying to help you guys keep from making some careless errors as we go through here. I would make my first step here a very small step. I would rewrite this as x over 3 plus 1 over 3 minus x over 2 equals 2 minus, if we distribute here, 2 over 6 is the same as 1/3, minus would make that a plus, x over 6. And then my common denominator would be 6, right? I've got 2, 3, and 6. So my least common denominator would be 6. So I'm going to multiply everything in this problem by 6. So it's going 1, 2, 3, 4, 5, 6 places all together. So we'd have 2x plus 2 minus 3x equals 12 minus 2 plus x. So 6 divided by 3 left me 2x. 1 divided by 3 left me, or 6 divided by 3 left me 2. 6 divided by 2 left me 3x. 6 times 2 was 12. 6 times 1/3 was 2. 6 times 1/6 was 1. Yeah, we're good. All right, so then if we think about like terms, we've got like terms there. We've got like terms there. So what do we have? We have negative 1x plus 2 over here equals 10 plus x over here. So we could add the x to get rid of that and subtract the 10 to get rid of that. So that would be negative 8 equals 2x. Divide both sides by 2. And we end up with negative 4 equals x for our 1 and only solution on that. Negative 4 equals x. All right, that takes care of that one. So again, the reason I did that first step where I broke those into or did the multiplications where needed, otherwise you guys tend to be a little bit careless when you're doing the distribution of the 6, and you don't always get that done correctly. If each term only has one piece, your success rate tends to go up and you avoid some careless errors. We go into page 3 here. If you do the help me solve this, they eliminate the fractions. You guys are all using calculators anyway. There's not a huge advantage to doing that. I probably would just let my calculator do the work for me. So for this one, we could just subtract 4 from both sides. So we'd have 3.4x equals, and then we have 6.1 minus 4, which would be 2.1. And then we can divide both sides by 3.4, which would say x equals 2.1 over 3.4. Now, we don't leave fractions with decimals inside of them, so we would go ahead and change that answer to 21 over 34. 21 and 34 do not have any common factors, so that is reduced. So 21 over 34 would be our final answer. Then in part B, we start with 0.02 times x plus 3 minus 0.03 times 2x minus 3 equals 0.12. So the first thing we're going to do is distribute and distribute, which would give me 0.02 times x plus 0.06 minus 0.06 times x minus makes that a plus 0.09 equals 0.12. So then if we think about like terms, we can combine up our x's and our constants here. So if I have 0.02 minus 0.06, that would put me at negative 0.04x. 0.06 plus 0.09 would be a positive 0.15 equals 0.12. So then we can subtract that 0.15 from both sides, which would say negative 0.04x equals negative 0.03. Divide both sides by negative 0.04. We're going to have x equals, can we go ahead and do that multiplication as we go? Move the decimal 2 places on both of them. So x equals 3/4 is going to be our final answer. We had 0.03 over 0.04, which is the same as 3/4. Negative on top, negative on the bottom. When you do that, those end up coming back as a positive for your final answer. Example 5 says the amount of solid waste in pounds, so waste is in pounds, created by the daily by the average American during year X can be approximated by G of X equals 0.04 times the quantity X minus 2005 plus 4.5. Estimate when this amount could reach 5 pounds. So X is the year, not the amount of waste. So we don't want to be plugging in 5 for the X because we're not talking about 5 years, right? So instead, we want to plug the 5 in for the G of X. The whole thing, remember, is one quantity. That's your Y. So we're saying our Y value is 5 equals 0.04 times X minus 2005 plus 4.5. So if we distribute first, we would have 5 equals 0.04 times X minus, if we put in 2005 times 0.04, we get 80.2. And plus 4.5 that was still back there. So when we combine that, we've got 5 equals 0.04x minus 75.7. So what I did there was just combine those two like terms. Now we can add the 75.7 over here. So 75.7 gets combined with the 5, which puts me at 80.7. Equals 0.04x. Divide both sides by 0.04. 2017.5. Now be careful on this. 2017.5 would be June, the 6th month of 2017. Don't round that to 2018. Think about the context of the question. What that means is we're halfway through the year 2017. So our year would be 2017. The waste per person would hit 5 pounds. Okay, so in the year 2017, the waste per person would be hitting that 5 pound mark that they were asking about. For the next one, they ask us to identify each equation as a contradiction, an identity, or conditional. This is something we have to do the work to figure out what our answer is supposed to be here. So for part A, we start with 5 minus the quantity 4 minus x equals 1 plus x. So if we distribute, we get 5 minus 4 plus x equals 1 plus x. If we combine the like terms, 5 minus 4 is a 1, plus x equals 1 plus x. Now you should recognize it right there. Left side is exactly the same as the right side. But if you didn't, if we continued solving this, if we subtracted x from both sides and subtracted 1 from both sides, we would end up with nothing over here, or 0, and also a 0 over here. When does 0 equal 0? Always. This is an identity, which means your solution set is all real numbers, which is an R with two verticals on the R. So it's an identity, which means your solution set is all real numbers. Pick any X that you feel like, you plug it into that equation, it will come back as a true statement. It doesn't matter what X value you pick, it's always true. Then if we look at part B, they start us off with 3x minus 1 equals 4 times 1 minus 4x, which says 3x minus 1 equals 4 minus 16x. So if we add 16x to both sides and add 1 to both sides, we would have 19x equals 5. Divide both sides by 19, and we have x equals 5 over 19. That is the one unique solution. That means this is conditional as far as answering their question. And if we look at part C, it starts out as 3x minus 3 times 2x plus 1 equals negative 3x plus 3. All right, so if we do our distribution, we have 3x minus 6x minus 3 equals negative 3x plus 3. If we combine the like terms, we have negative 3x negative 3 equals negative 3x positive 3. So if we add the 3x to both sides and add 3 to both sides, that's going to say 0 on this side equals 3 plus 3 is 6. And when does 0 equal 6? Never. This is a false statement. And if you get a false statement, that's what makes a contradiction, which means our solution set is the empty set, okay, which is a circle with a line through it. That's your no solution, the empty set symbol, as we're looking at that for no solution.